Hi guys. Man, that noise, do you miss it? So we are going to be going through lesson 7.3 today. You will need your study guide and intervention worksheet and your notebook. The first thing you're going to be in is your notebook, so go ahead and pull that out. Maybe label it lesson 7.3 and the date. You're going to pop that in there. So our main idea here is that for any non-negative, because you can't take the square root of a negative number, so any non-negative real number, if you have something to the power of 1/2, it can be rewritten as a square root or a radical. So 16 to the power 1/2 could also be written as the square root of 16. So remember that a square root is talking about squaring to the square root of 16. If you think about it, 16 could also be written as 4 squared. So the reason it's sometimes kind of nice to write those roots is because 2's here and 2's here. If you have an exponent and a radical, they undo each other. They're opposites, just like negative and positive are opposites, and multiplication and addition are positives. This is really amusing me because Einstein is just like creeping in the background of all of my videos and I'm getting distracted. But anyways, I'm going to keep my head in front of him just so he's not creeping on you guys because that's weird. Anyways, so when we have an exponent to the power 2 and a radical, they can cancel out, and that's why also we get 4 here. Sometimes it works out nicely, sometimes it doesn't work out so nicely, but we can at least try. Pause this video if you need to finish writing it down. I'm going to keep moving forward. So the first one that we're going to look at is this 14 to the power 1/2. The way I like to imagine it is let me move this out of the way. Get me out of the way here. So the way I like to imagine it is this denominator number here is going to swing around. Now with square roots, we usually don't write a 2, but if it's going to help you to be writing 2's, I would definitely recommend it. It never hurts to write extra there. I won't mark you down for it. I don't mind if you do that at this point. I think it's going to be really helpful. So you're going to take the denominator, you're going to swing it out and put it outside the spoon. That's this little like root thing. I call it a spoon. And then you just put 14 in there, and that is literally all you're going to do for these problems. So the square root of 17 is the opposite. You can add the little 2 there, and you're going to swing it the opposite way. And this becomes 17, not to the power 2, but to the power 1/2. And that is your answer. That's it. That's all you have to do for these problems. Do not overthink them. They're pretty straightforward, pretty simple. Give them a try. I'm going to jump ahead to problem number 7. So if you wanted to pause this video and try the ones in between, feel free to do that. So you can also do the same thing when there's a 3. Again, you're going to swing it around. And so this becomes 343 to the power of 1/3. Now this can actually be simplified because 343 can be factored out. If you write out a factor tree for 343, I can tell you right now, sometimes it might be a little bit of guess and checking. So you can always get your phone out. If you have a phone, you can pull out a calculator, whatever you need to do. And if you do not know what goes into 343, you can start from the bottom. So 2 can't go into it because it's an even number. So you could start with 343 and divide it by 3. I get a decimal. So we cannot do that one. So try 343 divided by 4. I get a decimal. That doesn't work. You could do 5, but it has to end in a 5 or a 0, so that one doesn't work. You can also try 6. That gets a decimal. That doesn't work. Let's try 7. That does work. That gives us a good number. So 7, when I tried to divide by 7, it was 49. 7 is a prime number, so I can stop there. And then 49 is nice because 49 is simply 7 times 7. So you might need to do a little bit of guess and checking, but you're basically breaking them down to their prime factors. So in this case, we have 7 times 7 times 7, or we could write it as 7 to the power of 3. This is still to the power of 1/3. In the last lesson, we talked about how a power to a power means you multiply. So in this case, you have 3 times 1/3. Let me write that out for you. If you think about 3 times 1/3, that's like 3 over 3, which is just simply 7 to the power 1, or just 7. You can leave it like that. And that's how you do those problems. 512 to the power 1/3, you don't have to put as a radical. I would leave it as a fraction, actually. And you're just going to factor it out with the factor tree, break them down, and work your way through them.